Hi everyone, in this video for 163.14 Combinatorics we're going to look at some basic counting principles, and we're going to illustrate them using this problem taken from the 2015 exam. So it says how many 6-letter words can be made using the 26 letters of the English alphabet, which consists of 21 consonants and the 5 vowels A, E, I, O and U. So firstly, letters may be used more than once. 2, no letter may occur more than once. 3, each word must contain exactly 2 vowels and letters may be used more than once. 4, each word must contain exactly 2 vowels and no letter may occur more than once. And lastly, each word must contain at most 2 vowels and no letter may occur more than once. Okay, so there's 5 questions there, putting different conditions on what the word can look like. The reason word is in quotes here is we're not actually talking about real words, we're just talking about stringing letters together. So it doesn't have to make sense. So we're allowed something like X, K, Q, C, D, Y, for example. That's just 6 letters taken from the alphabet in order, so it doesn't have to make sense. Alright, so to do this there's 2 main tools that we're going to use, and the first main tool is the multiplication principle. So let's just talk about that. Okay, so there's a formal statement here and there's an informal statement. The formal statement says let S1, S2 up to Sn be finite sets, and we'll let S be the product of those, so the Cartesian product. So that consists of S1 cross S2 cross ... cross Sn. Then the size of the resulting set S, so the size of that product of sets, is the product of the sizes of each of those individual sets. So it's the size of S1 times the size of S2 times ... times the size of Sn. Okay, and I guess the way that we tend to think about this is, so just the informal statement, if an outcome is the result of a series of n choices, and there are ki choices at each step I, then the number of possible outcomes is just the product of those ki. So it's k1 times k2 times ... times kn. Okay, so this is one of the fundamental counting principles. So just to illustrate that with an example, let's suppose that S1 is the set A, B, C and D, S2 is the set 0 and 1, and S3 is the set X, Y, Z. Okay, so then this Cartesian product, S1 across X1 times S2 times S3, consists of triples that look like big A, big little I, and big X, where big A comes from the set A, B, C and D, I comes from the set 0 and 1, and X comes from the set X, Y, Z. Okay, so we're looking at things like, say, A0x, then A0y, A0z, say A1x. So if I were listing them systematically, I could go off and do them like that. Okay, so we're looking at, and we want to count the number of things that look like that. Okay, and so what our counting principle, our multiplication principle says, that so the size of this product is just the size of S1 times the size of S2 times the size of S3. Right, and so that's so S1 has got 4 elements, so that's going to be 4. S2 has got 2 elements, and S3 has got 3 elements. So I'm getting 4 times 2 times 3, which is 24. Okay, so that's the size of this product. And if you wanted to go through and systematically list all of them, list all of those triples, that's what you would get. Okay, and so if I come back to this informal statement, as I said, it's the number of product of the number of choices, options we have at each step. So I guess really here I should have said options perhaps. So I want to make one of these triples. Well, I've got 4 options, 4 choices for what I put in the first slot, and then for each of those I've got 2 options for what I put in the second slot, and then for each of those I've got 3 options for what I put in the third slot. Okay, and so that gives me my 4 times 2 times 3. So just multiply the number of options I have at each step. Okay, so that's our multiplication principle, and that's our main tool. So let's look at that, just going back to the problem. Okay, so we've just got to back up here to remind ourselves. Okay, so the first one says letters may be used more than once. Okay, so this is the least restrictive of the question. So what I can do is I can think of my word as being basically consisting of these 6 boxes. Okay, and I'm going to just write, if I want to make a word, I need to just write a letter in each box as I go along. So maybe I write A first, and then D second, and then X in the third box, and I'm allowed to use letters more than once, so maybe I use A again, and then B, and then I finish with perhaps another X. Okay, so so we can think of the process of making one of these words as just a process of filling in each of these 6 boxes. Okay, and in each step, we've got 26 letters, so I've got 26 options here, and also here, and here. So at each step, I've got 26 choices for what I put in the box. Okay, and so the answer is just going to be 26 times 26. How many have I got so far? That's 4. Okay, so it's just, I should have just written it this way to start with. It's just 26 to the 6. Okay, so that's the answer to the first question. Okay, so for the second question, it says no letter may occur more than once. Okay, so we're just going to do the same process of filling in those boxes. So I've got my 6 boxes, and I just want to fill those in turn. Okay, so I've got 26 choices for what to put here. So maybe I put a D. Right. So having put a D here, I'm not allowed to use D again, right? Because the rule says no letter may occur more than once. Okay, so having put a D in here, I'm not allowed to use a D here, and so at the second step, I just have 25 choices. Okay, and that's because we can't reuse the first letter. Okay, so I've got 25 choices for what I put there. Maybe I put an E. Right, and so then having done that, I can't use D and I can't use E, so I'm down to 24 choices for what I put here. And then I'll have used up 3 letters, and so I'll just have 23 choices, 22, and then finally 21 for that last one. Okay, so the answer here is going to be 26 times 25 times 24 times 23 times 22 times 21. Okay, so that's our answer for this the second one, right? So again, we use that multiplication principle. We've got 26 options at the first step, then just 25 at the second, 24 at the third, and so on. Okay, so that's how we answer that second one. Okay, so moving on to the third question. It says each word must contain exactly 2 vowels, and letters may be used more than once. Okay, so again, let's just think about our filling in boxes. Okay, so alright, so let's be a little bit more specific for the moment. So it says each word must contain exactly 2 vowels. So maybe let's just get those 2 vowels out of the way to start with. So let's just suppose that we first look at the ones where we have where we've got vowels here, and then these ones are the consonants. Okay, so let's suppose the first 2 letters are vowels. Okay, well if I do that, I'm going to have, I've got 5 vowels, so I've got 5 choices for what I put in this first one. Okay, and then I've got 5 choices for what I put in here, because that has to be a vowel as well. And then these ones are all consonants, so I've got 21 choices for what goes here, 21 choices for here, and this one, and this one. Okay, so if the first 2 letters are vowels, then I'm going to have, so that's 5 squared times 21 to the 4. Okay, so that's the number of words in which the first 2 are vowels. Okay, but the question doesn't say that the first 2 are vowels, it just says that exactly 2 of them are vowels. Okay, so maybe we might have the first and third Okay, well then I'd have 5 choices for what goes here. This one would need to be a consonant, so that one's going to be 21, and then I'll have 5 choices here again, because I said that was going to be a vowel, and then I'll have 21 choices for the last 3. Okay, so again, I get 5 squared times 21 to the 4. Okay, so that's if the first and third are vowels, or the first 2 are vowels. And so essentially we get a 5 squared times 21 to the 4 for every possible way of choosing 2 of these boxes to be vowels. Okay, so so the way that we could think about building up this word is first we choose which 2 boxes are going to have vowels in them, and then we choose the vowels to go in them, and there'll be 5 squared ways to choose the vowels that we use, and then we choose the consonants for the remaining 4 boxes, and so that's going to be 21 to the 4. Okay, so how many ways are there to choose the 2 vowels, to choose which boxes to get the 2 vowels? So that's going to be 6 choose 2. So there's going to be 6 choose 2 ways to choose which letters are vowels. Okay, and so if we think about our process, first we choose which 2 boxes are going to have the vowels, and then we choose which vowels we have, and then we choose which consonants. Then we've got 6 choose 2 choices for which boxes to put the vowels in, and then we're going to have 5 squared for the number of ways we can choose our vowels, and then 21 to the 4 for the number of ways in which we can choose our consonants. Okay, so that's going to be the answer right here. And I guess that 6 choose 2 we could work out if we wanted to. That's going to be 6 factorial, 4 factorial, 2 factorial. So it's going to be 6 times 5 over 2, so that's 30 over 2 is 15. Okay, so that's how we do the second one, third one, sorry. Okay, so now on to the fourth one. Alright, so this time each word must contain exactly 2 vowels. Okay, so we know how to handle that. We're just going to get a 6 choose 2 for deciding which 2 boxes are going to have the vowels, and then no letter may occur more than once. Okay, so we saw how to do that in the first, on the previous page. So we're going to have 6 choose 2 ways to choose which letters are vowels. And then we're going to have 5 choices for the first vowel. And then we'll have used that vowel up. We're not allowed to use any letter more than once, so the next vowel will only have 4 choices. Okay, and then with the consonants, we're going to have 21 choices for first. And then we'll have 20 for the second, then 19 for the third, and then 18 for the fourth. So our answer is going to be 6 choose 2 times 5 times 4 times 21 times 20 times 19 times 18. Okay, so that's how we answer that second question. Right, so the key thing here was that we needed to get this factor, both of these, we need to get this factor of 6 choose 2 to account for the fact that we had some options for where to put the vowels. And if we just wrote down this 5 squared times 21 to the 4, then essentially we'd be just counting the ones that had, we'd just be counting the words that had vowels in 2 particular positions. Okay, alright, so on to the last question. So it says each word must contain at most 2 vowels and no letter may occur more than once. Okay, so what we can do here, it says at most 2 vowels, so the possibilities are basically 0 vowels, 1 vowel, or 2 vowels. Now we know how many ways there are to do this one. That's what it said, no letter may recur more than once. Okay, so we just worked that one out. It's 6 choose 2, and then times 5 times 4 times 21 times 20 times 19 times 18. If there's no vowel, then we only have 21 choices for the first letter, and then we've got 20 choices for the second, times 19 times 18 times 17 times 16. Okay, that's 6 factors there. And then for one vowel, well, we're just going to do it in much the same way that we did this one right here. And so we're going to have 6 choose 1, so that's the number of ways to choose which letter is going to be the vowel. Then we've got 5 choices for the vowel that we use, and then we have 21 choices for the first consonant, 20 for the second, times 19 times 18 times 17. So 1, 2, 3, 4, 5, 6. Okay, that's the right number of factors. Okay, so what I've got here is I've got, this is the number of words that have no vowel. This is the ones that have exactly 1, and this is the number that have exactly 2. Okay, so what do we do with these? Well, that's where our second counting principle comes in, which is the addition principle. Okay, so actually this one is kind of by far the simpler of the two. This one is, I guess, sort of actually the kind of thing you learn in primary school in a sense. So, at least my second example is going to be sort of kindergarten type example. So, not kindergarten, primary school. Okay, so let's say that S1, S2 up to Sn are disjoint finite sets. So this disjoint is important, and that means there is, so formally that means there's no intersection, which is the same as saying there's no overlap. Okay, and then what we want to do is we want to create the set S, which is the union of those. So it's S1 union S2 up to Sn. Okay, and then the size of that set S that we created, what we do is we just add up the sizes of the individual sets. So it's the size of S1 plus the size of S2 plus dot 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 plus the size of Sn. Okay, so just to illustrate that, our first example, let's use our S sets S1, S2 and S3 from before. Then S1 union S2 union S3, well, I just write down everything that's in one of those sets. So I've got A, B, C, D, and then 0 and 1, and then X, Y, and Z. Okay, and so if I just count up how many elements I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that 9 is exactly this 4 plus this 2 plus this 3. Right? Okay, so this is like, why am I learning this in TJ Mathematics? It's kind of obvious. All right, so okay, so second example, my orchard's got 7 apple trees, 4 peach trees, 3 cherry trees, and 2 feijoa trees. So obviously I just add those up to find the total number of trees in my orchard. I really wish I'd planted more cherry trees. I really like cherries. Okay, so what's that? That comes out to 16, I think. Yep, fuel. All right, so just going back to our problem. So we figured out that there's this many words with no vowels, this many with exactly 1, and this many with exactly 2. Okay, so we just want to add those up. Okay, so the total, just using our addition principle, right? Because there's no overlap between these, right? So a word that's got 0 vowels, there's nothing in common between these two sets or between any of these. Okay, and so the total is we just add those up. So 21 times 20 times 19 times 18 times 17 times 16 plus our 6 choose 1 times 5 times 21 times 20 times 19 times 18 times 17 plus 6 choose 2 times 5 times 4 times 21 times 20 times 19 times 18. Okay, and we'll just leave the answer like that. Okay, so that's I guess going back to the start. So that's that said, our two main counting principles are the addition principle and the multiplication principle, and this still illustrates just so basically when we use them. Okay. All right.